Okay, think we can start. Okay, so today, Lab 4 introduction to data acquisition. So let me put myself on recording. Okay, are you able to see the slides? I hope you can. You can download a copy of it. Okay, okay, it might be also useful if you also use the school computer to look at, try to use dual screen. Use the school computer, you can turn it on. You can look at some of the lecture notes on the big TV, right? Not the big computer. Then after that, you can use your laptop to do the LabVIEW programming. Okay, so that is the idea. Okay, so use the resources that is available. Right. Okay, so shall we just go on? We will start by just giving you a quick introduction to data acquisition first, right? Then at the same time, I will try to help you to attempt some of your lab exercises. Okay, there are quite a bit of theory at the front. Then later on, if you look at your lab sheet, okay, page 1, 2, 3, 4, 5, I think all the way until about page 6, then you got some exercise. Okay, so there are some theory. We cover some theory first. Then on page 10, where we will do some hands-on. Okay, exercise 7 onwards. Okay, there will be some hands-on exercises which you will do. Okay, we will do this today. All right. So maybe, okay, can I request one thing? Can you all now go to the back, the tape, Mr. Teo, can they draw the 609? So okay, what you do, I want you all to do this, so that later on the hardware got any issue, I can identify. If there's a hope, but shouldn't be. Okay, you go to Mr. Teo there, right? Now you look at your table number first. What's your number on your table, right? Then you go to Mr. Teo there and take a unit, that Mr. Teo will pass to you. So take the respective number based on your table number. Understand? Go look at your table number, what's your number, right? Then you go to Mr. Teo, you tell Mr. Teo what is your number. Then easier. So you all take your own set. The reason why later on, because we can identify the individual set if you face any issue. Okay, so quickly just go and draw one first. Draw one hardware, and then bring to your desk. Tell Mr. Teo your number, or you all can see yourself. What is the DAQ hardware? Come go and take. I should take 25. Take the last one. Come, you all just go and take. 16. I'll tell you, it's a data acquisition hardware. Okay, so it's a training set. We thought you can play around with it and control the light sensor. Okay, so quite fun. I think it's quite fun. Later you all play around. I'll show you how we get this thing working. I hope that you all got installed the driver. Hopefully you all got installed. The thing. Don't turn on first. See what happens. This thing blink or can detect. Maybe what you all do while you all quite excited, I hold the thing. There's a USB cable on the side there. Okay, I want you to plug into your laptop, your keyboard. Plug in first. Technically, you don't need to switch on the power because it's USB power for the beginning. You plug in the USB, right? You should see there's a blinking green light. If you see that blinking green light means that your hardware is your driver is installed. No need to turn on the adapter, the power adapter. In the USB. You see the hardware there, the one LED blinking. Blinking. Okay, good. Then you should see something pop up. Okay, do you see a green blinking light? I think yes. So hopefully you see a green light. Okay, so I draw one also. Okay, you see a blinking light means that your hardware is, your driver is installed. Quite exciting. What does this thing do? Okay, later you can take a look at the video. You can plug in first. The adapter you can turn on later. Technically, you don't need to switch on the main power first. Just the USB only. Just plug in the USB. No USB. Yours USB-C. Is it? Your computer don't have USB. Oh, okay. Not surprised because nowadays new computer all USB Type C. Yeah, maybe Mr. Teo. That one is our problem. If students don't have, they have to get a converter. Yeah, in case the student don't have the, then student go and get one their own. Yeah. Okay, Ken. Okay, so you're happy, you're plug in first. Okay, now relax first, I'll tell you what to do. Okay, but you can tell me whether you got blinking light or not. You know what I mean? When I say blinking light, it means I'm looking at this. You can see on my front. The hardware here on the USB, the board here. Here I can see. You should see a blinking green light. Yeah, I believe. Yeah, if yours don't blink, right, that means that maybe your driver never installed. This one, you see the side. You should see a green color blinking green light, LED, which is on this hardware. I want you to also examine this hardware. It's called, there's a National Instruments logo there, right? National Instruments is the company that make this Lab4 software and the hardware. Okay, and then it says it's a NI USB 6009. I don't know whether you can see that. Okay, so if you have it blinking, it's fine, it's good. Yeah, in fact, if you see my computer, if you look at my screen, right, guys? Wait. Yeah, if you happen to see my computer, right? Do you see this pop up? Don't do anything first, just relax first. Do you see this thing? Do you see this? Do you see that? Yes, okay, just leave it first. And this is good, means that your system is ready. Do you have this? Okay, good. Let's see. Who don't have it? Have okay. No, it's usually auto one. I think it will pop up. You can plug in again. Unplug, plug in. Have okay, good. Mostly have. That means the installation have. Go ahead. Go ahead. Where's yours? Okay, good. You want on the light, very sleepy, alright. Huh? Yeah. The two-way switch. You ask Mr. Teo. This side. Okay. Okay, never mind. Later I ask Mr. Teo. Got two-way switch. I don't know which button to press. Okay, so just hold on first. Hold on to this first, okay? Don't worry about this one. Okay, which is good. Once you see this, it means that the software has been detected, okay, for your hardware. All right, so maybe I start with some theory first, very quickly. Then after we do some hands-on. Okay, this is the most fundamental blocks. Okay, in what you call data acquisition. Okay, so this to me this is the most important block. Okay, that you must learn. You must know. Okay, so I just briefly mentioned now, starting on the left-hand side of this diagram. Okay, now whatever you learn, okay, whatever you are trying to measure is a physical phenomena. Okay, I always tell students we live in an analog world. Okay, our everything is physical. Okay, so if I ask you, what is temperature, right? Then you tell me, sir, today's temperature, is it very hot today? Very hot today. So some of you say, but a few days ago was very very hot, right? Last week, last week was terrible. I think, where one of the day was super hot. Yeah, but today I think reasonable maybe 32 degrees roughly. All right. Now this temperature is a physical quantity. Hope you understand. It's an analog value. Okay. So maybe you tell me today the outside temperature 32.1 degrees Celsius. Right. So it's a physical quantity. It is analog. I hope you understand what is analog. Okay. Analog means it's something that is numerical. Okay. Unlike digital, I think you all know what's digital, right? Digital. What is digital? What is your understanding of digital? Do you all know? What is digital? 1010. Good. You all can tell me that it's binary or some digital pattern, right? Yeah. Okay. But digital basically is just a representation from the analog. But you need to convert. Okay, from analog to digital. Okay, so which is this diagram is very suitable to explain, right? The what you do. We want to connect or convert either way. Okay, it can be both ways actually. But in this case, you see this picture here. Okay, there is a transducer. You see the picture there, right? That transducer is something like sensors. Okay, which measures the analog values, analog quantities, like a thermometer, right? Is a sensor, the transducer, because it measures the analog values like temperature in degrees Celsius and convert it into electrical signals. Okay, I hope you know. Okay, don't say, hey sir, how it works? You convert temperature into a electrical signal. Now the electrical signal can be in various forms like voltage, can be current, can be resistance, can be capacitance, and other things. Okay, but generally voltage is very common. Okay, a voltage from a temperature convert to voltage. Then only, right, the voltage signal, okay, will pass through something called signal conditioning, because sometimes the signal can be very small. You get what I mean? Can be in millivolts. Okay, very very small, right? And then we will then convert this so-called maybe an amplified voltage signal, into something digital, then the computer take over. Okay, so for example, like now, right, I'm speaking to you, right? Now, what am I using? Can I ask you? What is this thing that I'm holding in my hand? I think you know it. This is a what? Microphone. Now, it makes a difference when I speak like this or I speak like this. Right? Why? What is the difference? Because there's a microphone, right? So basically, it's a transducer, okay, or like a sensor. It converts my air pressure that I'm speaking now. Right? Why I'm speaking is just air pressure, okay, or waveform, wave. Convert it into what? Convert this air and convert into some electrical signal, right? You can think about it. Something inside going on. Now, it doesn't just happen by itself, because why? This is wireless, right? This signal is converted into a form. Then it is what? What is the thing? The sound is what? Can I hear the word? Amplify. Thank you. I was waiting for the word. Okay, I'm waiting the word that coming out from your mouth. Okay, the signal is being amplified through an amplifier sitting on my table here. Okay, so you can see that because, what is the reason I'm doing this? Because I don't want to shout, right? So I just speak normally, but my voice is being amplified. Alright, amplified many times, larger, right? So that you all can hear, the person at the back can hear me. Okay, so you can see that, so signal conditioning, something very simple and something you can relate is amplification. Okay, to amplify the signal. Alright, then it then goes to the data acquisition. Okay, which I will explain to you later. So, but everything inside this data acquisition block here, everything is digital. Alright, it convert the analog signal into digital signal. Why? What's the advantage of digital signal? Because you can process it easily. Okay, so this is another quick sample. You are able to find the slides. I hope you all can see where the slides are. Justin, can you find the slide? Can. Okay, so very quickly, now I'm going to help you with the first one. Okay, very quick one. Okay, recap. Okay, binary system. This one. Now, in your Lab4 exercise, I think it's which one? Page 2. Can you all turn to page 2 of your lab sheet? Yeah, Lab4, page 2. Okay, so this asking you something about the binary pattern. I don't know how much you all remember. Okay, so you take a look first. The lab page 2. Okay, page 2, they talk about this thing called the binary pattern. Okay, I don't know whether you can remember or not. For example, I got a 4-bit system. Okay, I start with this. Start with something really simple. You all remember this? You all recall? This one. This is 2 what? N minus 1. This one 2 to the power 0, right? 2 to the power 1. 2 to the power 2. 2 to the power 3. Can you all remember this? Then 2 to the power 3. So what are these things called? This is called the binary weights. This one, I hope you remember. So I just draw a simple table for you like this. Okay, then I put the digital value, digital number. Digital number. This number should be 0 first, right? Okay, so I believe you know what is the next one. You all know what is the next number? Can you remember this one? Can see now, guys? Yes. So rewind, you all can see. This one. 0, 0, 1. You see, I cannot see, then come a bit inside. Then remember. So what's the next number? What's the digital equivalent? Base 10. This one is base 10. Base 10. Base 10 is our normal number that we learn in primary school. Can take picture. Later take for you all. Yeah. And take picture, send to the group. Okay, so this is number 1, right? This is number 2. This one is base 10. Remember. Now, what is the last digit? Can I ask quickly? What's the last number? 15. Thank you. How you get 15? Do you memorize or what? How you get 15? How you know the number? This last digit. Very good. 2 to the power n minus 1. Alright, can you all remember this? 2 to the power n minus 1, 15. Because how many bits are there? What is n? What is n? Number of bits, right? Number of digital bits. So in this case, n is 4. Okay? Right? N is 4 bits. 4 bits, right? 4 bits can represent how many numbers? Can I ask? I'm not going to write because this one is like a long list, right? 16. Long list all the way. 1 all to 0. Start with 0 all the way to 15, right?
16 numbers including
16. Are you sure 16? 16. Alright. 16 including 0, right? Okay. So what Justin said, the total number of numbers you can represent, total number, right? Sorry, I only brought red pen. You all cannot see. You need to take a picture, send to you. Okay. Total number means it is 2 to the power n, right? Because like what you all say, 2 to the power of 4 is 16 representation. Agree? 16, I put representation. Because why 16? Because 0 is included. Agree? From 0 all the way to 15. Okay, total number of representation is 16. 16 levels or 16 steps, whatever you want to call it. But 16 representation. But the last value, the maximum value here, the max value, okay, I call it the max value, maximum, right? It can represent the largest number, max or the largest number, right? The largest number that can be represented is 2n minus 1, which is 15, right? Which is what you all agree with. Okay, understand? Very basic. Okay, do you think you can, of course, in the VI that you all just now downloaded, I asked you all to download something, right? So let's have a quick look. Those watching online one cannot see obviously what I wrote on the board, but they can see my screen. Okay, the student copy. So you got this, right? Okay, so are you able to see this VI called binary representation? Okay, let me, wait, let me, where's my Zoom? Wait, where's my Zoom tool? Here. Okay, so let's go back to my file here. Okay, zoom in. Now the students online one later they will be able to see. Now after you download this student copy, you have all the VIs there. These are for you to help you to attempt the Lab4 exercises. Some of them. Okay, so maybe you want to open up the first file first, called binary representation. Okay, let's take a look. Don't need. Wait. Okay, you get something like this, right? Okay, now you can of course don't scare yourself looking behind the block diagram. That not scary actually, not scary, but it's interesting. Okay, so I think they ask you to fill something over here. Don't know whether you saw or not. But basically, right, what this program does, it has two parts. Okay, it has two parts. Okay, you can see. Let's start with the first part. Okay, so the first part is that it allows you as a user to convert binary to decimal equivalent. Okay, how does it work? Very simple. Why don't you click the run button? When you click this run button, you will see this number flash out, right? Now, these are the two red color flashing number there are basically decimal indicators, correct? You can see now. So it means that you can play around with this binary pattern. Why don't you try? Okay, play around. But be careful. Be very careful one thing, because the LSB and the MSB, I don't know whether you remember or not. Most significant bit, this one is the least significant bit. I write it in another way. I swap it around. Do you see? It means that on my whiteboard then, the MSB is on the left side, the most significant bit. My LSB is on the right side. But I think this picture here, it is opposite. swap, but you have to make, but how to calculate is shown below. So you turn on, right? For example, at this point in time, you look at this one. I only switch on the most significant bit. This one got how many bits? Can I ask you? Can I ask you how many digital bits are here? How many? Huh? How many bits? Can count, right? Wow, can count, right? How many? How many? 8. Is it 8? 8 bits. Correct. 7 or 8? 8. You sure? 2, 4, 6. 8. 8 bits. 8 bits. Correct. 8 bits, right? You can count, right? 1, 2, 3, 4, 5, 6, 7, 8 bits. Okay. So I just turn on the first bit only. Okay, which is the most significant bit. Now, how I get 128? Can I ask you? How I get 128? How? How do I get 128? That number there. What is that number there? That one is the width, right? Do you understand? The width, which is 2 to the power of 0. On the left hand side. The least significant bit, 2 to the power of 0 is 1, right? Then followed by the next one next to it, 2 to the power of 1. You start from 2 to the power of 0, right? Then 2 to the power of 1, which is 2. Then 2 to the power of 2 is 4. Then 2 to the power of 3, 8. Then 2 to the power of 4, 16. 2 to the power of 5, 32, and so on. Understand? This one, I think you all know. This one, I hope you remember. This one from your year 1 digital electronics. Okay, if cannot remember, have to catch up a bit. Hey, have you all download this CI? Okay, now you look at your lab sheet 4, Lab4 lab sheet, right? The first part. Okay, you think you can fill up the first box? What do you think? Now you're trying it. So try to play around with the binary pattern so that it generates the different decimal. Okay, done already. What is the binary representation of 182? Yes, of course you can use calculator. Definitely, I won't stop you. You can use calculator, no issue. Okay, but I thought that it may be good that you can see on computer screen how we convert the numbers. You all put together, I'm okay, but please all do your own stuff. Okay, and you all can try to, okay? Because at the end, practical test is individual. You all know. So it's better to learn, but practical test is individual. You need to do by yourself. You'll be seated on individual table and you're not allowed to use your own laptop. Okay, you'll use the school computer. Individual, and there will be no Wi-Fi, no internet. Okay, during the test. And then all your handphone all will be kept for you. I will keep all your handphone.
Wait, no Wi-Fi, then how you
Can.
run that?
Can. Lab you can run without Wi-Fi. Why cannot? So on the practical test, it's just you and the lab in the school computer. Nothing else. No Wi-Fi. Okay. No connectivity to the outside world. No WhatsApp. No Wi-Fi. Okay, come. Let's help you. So have you keyed in the number already? 182. I don't know. So the okay. So I forgot to explain that the second part at the bottom. At the bottom of this program here, you got the decimal to binary. Sorry, but okay. So you need to type in 182. Okay, it's very easy only this program. Just ask you to key in only one. Okay, so I just done the first part for you already. I enter the 182. Okay, and I copy down the binary pattern. Okay, into your lab sheet. Is it okay? Very simple. Simple stuff. Now you then you want to do faster, you can go ahead first. Do a bit. No need. Later. Recording. Don't record anything first. This one very simple. Don't record first. Later I will tell you. Is it 7? Why you think it's 7? Okay. Think first. Okay. Totally think. Okay, my friend. Okay. Okay, Ken, shall we let you think? Okay, so I think the first two you can do. How about part C? Now, if I want to represent a decimal number 90, right? How many bits do you think I need? How many? Huh? Let me try and understand. Whether how many? Then part C.
Oh, 7.
7.
Calculated.
7. Okay.
Because binary calculator.
90.
Yeah.
Why 7?
01011010.
Yeah. So okay, maybe okay. So you try to find out what is the maximum representation, right? By the number of bits, right? You get what I mean? And you see whether your number can within that range or not. You understand? So you say 7, right? 90. Okay, let's just do one example. For the decimal 90, okay, decimal 90, right? Decimal number 90. Okay, one of you say that, hey, why don't I try 7? You can do a bit of trial and error, right? 2 to the power of 7. What is 2 to the power of 7? 128. 128 minus 1, 127. Okay, so what did I say about this number? This is the maximum number you can represent, right? If you use 7 bits, you can represent up to 127. Let me take a picture and send to your WhatsApp in case you want your cannot see. Make sense? Send to the class. If you use you want you yeah. Yeah, I just send you on. Okay, so you would use 2 to the power of 7, right? Can you use 6? Can I ask you a question? Can I use 6?
It gives
Can you use 6 bits?
It gives max 63.
Yeah, so what do you think? If you use 6 bits, can
No, because there's more need like the max.
Yeah, correct. Okay, good. You are thinking. So if I use 6 bits, then I got a problem, right? I cannot use 6 bits to represent it. Alright, make sense?
Yes.
6 bits cannot be used right here now for you all to see. So if you use n equals to 6, you got a problem. Why? 2 to the power n minus 1, right? It's the max value, right? I call it the max value. So 2 to the power of 6 minus 1, what do you get? Justin, what do you get?
Sorry?
63, right?
63.
Yeah. Okay, so 63 cannot represent number 90. Make sense? So I need to increase the next bit to 7 bit. You understand? This is how you do. You can try and error, but you can, if you are experienced, then you can straight away tell me. No need, sir. Just use 7 bits to represent. Now, can I use 8 bits to represent? Or I use 12 bits to represent? Can or not?
8 bits, sure.
Can I use 12 bits? Maybe I just purposely exaggerate. I use 12 bits, can or not?
A bit too much.
Can I use that? Then you test. You ask yourself. Okay, let's try it. 2 to the power of 12 minus. Confirm can what? Okay, can somebody press for me? 2 to the power of 12 minus 1. So it's what? Is it some.
4095.
495, yes. Okay, you can represent 495 decimal. It's a decimal number. Of course you can. But why? You don't want to do that.
Because you just get like a bunch of zeros at the front of that.
Yes, correct. You get a bunch of zeros at the front, and it's wasteful, right? Right now, I'm only representing decimal 90 only. Or why I need so many bits? Right? I don't need, right? I don't need so many. What? Do I need to use? Do I need? That's why I told you before, right? I don't know whether I tell you this example. I want to move one chair to Makam Place. Remember last time I told you? Do I need to call a lorry? And now, Oh, yeah, no need, right? If you want to bring a chair to makan place, I don't need to call a lorry. No need, right? Don't need to call a 3-tonner, 3-ton lorry. No need. Why? So such a small thing, right? I can carry myself. I'll just put a trolley, push the trolley up, right? Or I maybe put into a car also, okay lah. Okay, but don't overkill. Okay, what I call overkill. Overkill means that you don't put in so much resources to do something simple. Next time you all go out to work, if you do overkill, your boss will scold you. Why? Boss will scold you. Why? You wasteful. Alright, so be careful. You must save money for the company also, right? If the boss asks you to do something, think of a good way, and then you're a good worker, then the boss like you. Wow, this guy think for the company because you try to save money for the company. Then your boss appreciate you. Okay, something like that. You get what I mean? Remember, you don't anyhow waste the thing. Then boss, not so nice, right? Okay, so I think you can answer the whole page 2. I will help you with the part F. What is the name of the electronic circuit? That is called an analog to digital converter. You want to write down? Write down. The part F, right here, part F. There's one part F in your lab sheet, page 2. What is the hardware? It's called ABC. Okay, analog to digital converter. Digital, not device. Digital. Analog to digital. Hey, anybody tomorrow you all got duty one? Don't know, some student volunteer, right? There's a graduation duty. How you got duty? You all got your blazer, yeah? Got. How you got duty, right? Help out in our graduation ceremony. Hey, some of you. Yeah, I'll see you there. I'm the MC. Yeah, I'm the MC. One of the MC. There are 2 MCs. I'm one of them. But anyway, afternoon. Mine is 1:30. I don't know your session.
Oh wait, then can I pass you my worksheet then?
Don't do that. You all be nice. What, right? Then carry worksheet. Bit weird, right? Ask me to carry one. Bit weird, eh? Put in a pigeonhole, okay? Put in a block 7 only. Just next door.
What level?
Go to the general office. You just pop in there. Can? Can. Okay, I think okay, for the hexa, what do you call that? There's one question, right? What did they ask you to do? Exercise 1B. So I presume you all can do page 2. Any question? Maybe anybody not clear what to do? Want to ask question? Feel free. Page 2 can. Yeah, page 2 I leave you to try out, fill up the blanks. That one quite easy. Then how about page 1, exercise 1B? What did he ask you to do? Refer to the YouTube thing, right? Wow, how to let your key in? Jialat. How? You all ask to save a copy. Yeah, ask you to do something, right? Can do or not this one? Because I think there's a blank here for you to fill in. Can you try? Sorry, I don't have the QR code. Next time I must improve. Put a QR. But you all know, if you can go to the soft copy, then you can click on the link. Right? It will teach you there's a little activity there. Yeah, to convert, what is that? Fill 1B, fill in your code. Ask you delete the rectangle box. But you put your code there just for placement. How to convert to hex? How to convert to octal? Can try not? This one. Look at the YouTube. Look at the YouTube. Want me to send you the link? Maybe I should. Look at the YouTube. Huh? Registration. I don't know. You ask him. And ask him. Hey, how you get yourself volunteer? My friend there. Yeah, how you get yourself volunteer to do the usher? Huh? Who you approach? Huh? No. Kena arrow. Huh? They email you then ask you to do. Oh. Oh, like that one. Not volunteer. Oh. Yeah, I don't know. Yeah. Interesting. Oh, I'm not very sure. Oh. Oh yeah, lah. If you want to get CCA points, right, might be quite interesting. If you want CCA points, I think then go and volunteer yourself. Every year got one. This graduation, yeah. I can volunteer, why not? I can volunteer one actually. If you yeah, but I don't know who is in charge. Must inform somebody. Okay, let me give you this link. Okay, so can I ask you all to okay look at this video? Okay, wait. I'm going to share with you the link. Can you all attempt exercise 1B? Now. Okay, you might want to switch on your recording. So can I request you to wait, let's see. Yeah. Okay, let me give you exercise. What is this thing here? In 2 weeks time, you see your lesson plan. Every package is 2 weeks. I think it's fair lah. Okay, let me share with you guys. Okay, this one from this YouTube. I know you don't have the QR code but I'm going to share with you so that you all can do this activity. Okay, can you please turn on your screen recording for your from the Polite Mall, right? Okay, I share with you now. This then you all try to attempt this. Okay, send ready. See your WhatsApp. Okay, can I request you all please turn on your screen recording under the video screen recording task for Lab 4 under your class PG22. Everybody can help. Come around and see. Okay, turn on your screen recording, then we can do this activity. Shall we? Later this one can upload at the end of the class. And we might is to enable your screen recording and your other tools. Also good as a form of recap do it this way. Okay, do this one. There's no harm There's no harm to just recording the screen. Later can recap how you do the activity. Okay, turn on capture the entire very good. Then just click record. Okay, that's great. Okay, can I ask you 100% attention? Okay, let's focus. Okay, we try to finish the exercise at time. Can you enable your recording? Okay, good. Okay, so you see how to convert. So you help me to fill up that box there, how to complete. You can study the code a bit, how to do this. You can use the simplest way, right? Do the simplest way. Just let the recording run. Don't worry. Just let it run. Just let it run. It's okay. Maximum 2 hours. Oh, I was told you can record up to 2 hours. Just let it run. No issue. Okay, how to convert? Can I ask you first? Let you all try a bit. Make an attempt. How to convert to How do you convert to hexadecimal? Is there some function here? Is there some function? Convert to hex. This one, how? Hexadecimal, just maybe a quick one to help you in case you all forgot already. Hexadecimal is base 16. Okay, just to scribble here. Hex value is base 16. Sorry for the red ink. I don't have other color pen. Hex is base 16. Base 16. I hope you remember. So basically, base 16 means that you can represent your number 0 all the way to 9, right? 0 to 9. After 9 is 10, right? 10 is represented by A. Then A is number 10. Okay, then B is 11, right? Remember? C, D, E, and F, up to F. Okay, so F is 15. Understand? We all remember, right? How do you create how you use converter? Very smart. How to convert? Convert to base 16. Base 16, I'll give you a hint. Alright, to convert that, you need base 16. Hexadecimal. I'll let you try first, see who can get it. What is octal? Somebody also trying. I saw somebody trying to use the conversion. It's correct. Correct thing to do. You need to convert. Watch the YouTube. See how to do. Try. Try yourself. Try. Don't wait for answer. Try. How do you wait for answer? How do you do? Convert. For record. Then you know how you do it. Then you try lah. Why don't you put in a number? Then you put in a number, right? Then you will tell you the answer. Then if you put in decimal 74, your hex value should be 48. Then you know it's correct. Or you put in decimal 15, right? It should show you FF. Wait, if you put 255, then it should show you FF. Okay. Right? Or use calculator. Okay, use calculator check. Put in decimal 74, you should get 48. Right, you get 48. You get FF, yeah. Okay, but you show the X value? The display. You run this easy, right? Okay, very simple. Then you put 24 is 48. Yeah. But you put 255, you should get FF. 255. Enter. Then you run. Then you do. It's not updated. Why? Connect. Or wrong. Nothing fun. It's not moving. This part is fine. This part. Is it linked? Correct. You should change, right? Change the value. Oh, it's already here. Okay. Yeah, of course, you can check with the calculator, but you get 40. But can you change other values? This value is this one, right? You put 255. FF, correct. So can get it. Go. What do you do?
I just put that comma.
Yes, correct. Very good. Okay, some of you managed to get it already. Can not? Okay, 255, you get FF, right? That's the FF. For the in one correct. Okay, good. Some of you can do it already. Thank you. Just come here and come here. Okay. FF 255. So this part also, this guy. What? This one no need to mark. Only mark the one that you just did. The one I will mark off later.
This is for you. This is for you. For the best time machine. And on this song, you can also take it.
And look at the next part.
Okay, but
Try. Do the next part. Do the next part. How you can do it? Even the octal number also can change. What's octal by the way? Have it, what's octal? Octal number is base what? 8. Correct. Octal is base 8. Correct. Hexal is base 16. So different number, different representation. You have to do conversion properly. This is what you do already. Let me help you to sign off.
she's there. What they gonna do?
How do you come up? Why is it? That complicated. not supposed to copy.
Okay, ladies and gentlemen. Okay, what is the meaning of resolution, code width, and sampling? This one is inside the notes. Okay, now maybe I also suggest you very quickly you can catch this video. Then you can find the answer there. Okay, in case some of you are doing the next part. Yeah, some of you are looking. Why don't I suggest you watch this one here? Click on this quick video. You will explain to you. Then you write what is the meaning of resolution, what is code width, what is sampling. These three things can be found in here. Okay? This one, the what is the explanation there? That one you can quickly watch or you can refer to the notes. Okay, refer to the notes quickly, and then you can fill up this three part here. Are you done? Okay, quickly. Okay, so consider the benefit outweighs the disadvantage. Always more advantages. Okay, so shall we continue? This one I think you download. Okay, you can watch this short clip first. Okay, what is sampling? What is code width? What is resolution? This one I let you fill out first. I will only help you later part. I want to later on focus more on the hard theory, the practical side of things. Okay, so the theory part, because there is some so-called training video recorded for you already. So I will ask you to skip page 4 first. Okay, page 4 and page 5, don't do first. Okay, we will jump the order a little bit. Today we will jump the order a little bit. Okay. Because I want you to do some hands-on in class, so to speak. Okay, so we will ask you to, this one I let you, okay, so the page 4, wait, let me see. Page 3 to 5, page 3 all the way to page 5, you skip first. you finish for me exercise 1B, then you skip page 3 to page 5 first. Okay, we will do the lab first. You understand? Because you are in the lab, we should use the time to do the lab thing rather than the theory thing. Because you can do outside classroom. Theory one, no need later. Okay, so I quickly let you all finish the exercise 1B. Make sure I sign off on your exercise 1B. Okay. Okay, so temporary page 3 to page 5, don't do first. All right, do later. We will give you time to do. Okay, how are we doing? Okay, if you want to do some theory, it's okay lah. But I'm not saying you cannot do. If you want to do some of it, no problem. I want you to watch this next part of the video. How to do this thing called the MI Max. Which maybe, before that, maybe you should watch this one first. Introduction to this DAQ board. This one. I want you to watch this one. Cannot. Okay, ladies and gentlemen, so in case you finish your exercise 1B already, may I request you to start looking at the next activity. Next activity is to watch this demo. This one. Watch it on your own screen. This one. Exit the thing. Don't close up. Oh, no. Does it stop you? Okay, now like I'm recording, right? You see, I'm recording. I play this one. Nothing, Huh? No, No, it's still recording on it. You see the bottom. I never stop. Don't click stop lah. Unless you click stop, I cannot help it. No, still okay. Don't click stop lah. Right? Don't. Just don't click on this button. At any point in time, just let it run. Don't care about it. Just let it run. Just ignore it. Click on this. Then can you try lah? Try. Wait. Stop. Use Chrome or what? I use Chrome. I don't know what you use. I don't know. I use Chrome. You see your video still there? No, you use Chrome. I use Chrome. What about you? Chrome. If we watch the video clip, the DAQ demo board. This one important, okay? I must emphasize today lab super important. You watch this one first. This one super important. Your practical test is testing you this thing. Ladies and gentlemen, this one take it serious. This one practical test week 7, you are going to be tested on this hardware. DAQ. Make sure you must know the inside out of this thing. Yeah, okay. So I need you to watch it. Okay, I don't disturb you. I let you watch. Watch first. Watch this one. You save me, that one. Save your exercise. Yes. Aircon a bit cold. Yeah. Yeah, a bit cold. You haven't signed. Can I see your screen? Your water break, toilet break, self-service. To the, yeah. Clean the tendon. Key on the phone is quite useful. Here's the class attendance. Today is the 6th. This is PG22. Today is the 6th.
Yeah, my fair is like shit.
So you understand now? You will watch the guess the hardware now. If I ask you, okay, if I ask you where is the temperature sensor? You watch with your purpose. Identify the temperature
Hey, bro. Ooh, so I really is like completely not. Right.
Oh, there.
Okay, after you finish watching, right? Okay, you understand. Okay, I'm going to ask you on the box, where is the temperature sensor? Where? Which one? Make sure you know. Don't just really just watch the video mindlessly. Okay, do you know where the temperature sensor is? Physically point to me. Which one is the temperature sensor? Wait, watch again. Wait, watch again. Yeah, I'm not sure. Don't know. Which one is the light dependent LDR? Which one? So you know, don't just mindlessly watch the temperature sensor. LDR. Very good. Okay. Then of course LED push button. Correct. Okay, very good. Then where's the buzzer? It's inside. Okay, that means you watch. You watch and understand. Get yourself, get your orientation, get you familiar. You know. Okay, no need to test it. That means you know. No need to test it. Okay. Then we're going to do the next thing. Watching the thing, if they ask you where is the temperature sensor, you know. Okay, correct. Yes. Okay. But no features, no features. Push button. Yeah, of course, this one is the most important piece. Yeah, lah, it's push button. Yeah, correct. Okay. Okay, so you'll see the video. Okay. Later on, right, we are going to play around with it. The video quite clear, the explanation quite good. Video quite clear. You spend a lot of time, you're making all this video, you spend so much time. Make all this video for you. Okay. Alright, so I think you all get a good sense of this hardware. Okay, we are going to. You want to take a 5-minute break first, maybe? I think you all deserve a break. Toilet break, get some water. Just let the thing run, don't worry. Okay, later on we come back, we will do some hands-on, okay? Yeah, we're going to do some hands-on. Okay, you all go for your quick break first. Don't leave the building. Just stay within the building. Don't, go and get water, whatever, okay? But don't exit the building. So far so good. I think you all so far so good. Yeah, I need water. I need water. Yeah, go ahead. Toilet break, water break, toilet break, bio break, or whatever break you want to call it.
It's really important. They always say
What you saying? More help.
I don't know how to put in
Ken, is it okay?
Yeah.
Ken,
Somehow I can't like open the API inside. Because like when you try and like run noise DC signal, right? You have to do the change T, the change TF sub PI and there are two sub you have to do the somehow I don't know. But yeah,
Yeah, just make sure after you're watching the video, you can identify all the elements inside this box. Okay, where the temperature, got unzip or not? Never unzip. Unzip the download. Then, remember, okay? Always remember, never mind, sometimes you forget. Unzip first, then only you can run. Yeah, unzip Justin. Unzip it should work. Okay, how have you done? I haven't seen yours. I haven't signed yours yet. Can I sign it? Yes, sign it. Sign up before. Where do you want?
It's always you get screen here, so I think because nobody cannot do it. Exactly. So they tell you to write the time you have to
What is the temperature sensor called? You all know not? What is the name of the temperature sensor? You all know? LM335. Very good. LM335. Make sure you know. What is the temperature sensor called? What is the temperature sensor called? Pop quiz. Yeah, but what is the name? Ask Kelvin. Kelvin maybe know. Kelvin, what is the temperature sensor called? What is the name of it? Quickly go and see lah. Quickly. Better make a note because we need to know that one. The temperature sensor. What's the name of the sensor? Wayne, do you know? What's the name of the temperature sensor? What is the DAQ called? What's the model? USB what? 6009. Okay, very good. Okay, you must know. No. You must know because we're gonna use it, right?
What the temperature sensor is?
LM.
LM?
What? It's inside the video. You all watch. That's why when you all watch video, you all must watch mindfully. There's a difference, when you watch it mindfully and mindlessly. Make a difference, right? Okay. Okay, can. So shall we get back? Okay, I'm going to skip the theory part first because I feel that in the lab the theory part can do later. Alright, so don't worry. If I skip later, can come back again. Unzip, right click, unzip. Unzip, right? You really unzip already, there, the copy there. The second one, yeah, you want to unzip already. Second one, the one at the bottom. Yeah, this one is unzip already. So you should be able to run. Don't open the sub VI, open the main program. Let's say sampling demo. Then open already, no broken arrow. It's okay. Okay, guys, ladies and gentlemen, shall we start again? Okay, so that I can later release you all on time. Okay, let's begin. Can you all take your seat, please? Come. Take your seat. Okay, we will now. Okay, I will show you something on demo. Then you all can also try to follow along. Okay. Now, in case some student may ask, but sir, when I go home, I cannot bring home this hardware, right? Because this one belongs to the lab, right? Not? So then at home, can I still practice? Can, okay? You can create this thing called simulated deck, okay? I'm going to show you how. Now, first thing first, you already plugged in, right? Your hardware. Okay, I believe just now I told you this one you still have or not. If you don't have, don't panic. Just now I asked you, right? Okay, I'm going to close this one. I don't need this already. I'm going to close this one also. I just going to leave. Okay, very messy desktop here. Okay, let me hide it. Okay, like that. Okay, can we see this one only? For our friend there who don't have this thing, right? Don't panic. You can always type NI Max. You can click on this NI Max, right? You will be able to find this device, this pop-up thing, right? Don't worry. If you don't have this, don't panic. Okay, wait, I'm going to ask for those of you who have this pop-up window, I think you still keep it there, right? I hope. If it's not there, don't panic also. If you have it there, it's good. Can you click on this call configure and test this device? Okay, everybody, it might be good if you also check your recording. Your recording still on or not? Because now this demo part quite important, so that later on when you can revise, you can review back your video. Okay, I hope your recording is still there. Hey, where's our friend there? 跑去哪里啊? There you go. Where this guy go? His laptop also missing. Okay. Okay, let's start. Okay, you click on this configure and test. Make sure your recording is still on. Keep your recording on so that you can later review these steps. Okay. So I want you to click on this. Okay, so some of you, when you click on this, it'll take a little while to run, right? I'm not sure about your computer, depending on how fast your computer is. Okay, generally it should be quite fast. Okay, so you should see this window, right? Okay, this is called the NI Max. Okay, I will next time call this NI Max. Max stands for Measurement and Automation Explorer. Okay, NI Max. Basically, it is a NI software that comes with it that allows us to use it to test our hardware without any programming. Okay, without any programming. Now, if you recall, I think some of you did this last week. I asked you all to create the simulated deck, remember or not? The last exercise, if you recall. Now, can I ask you to quickly check your computer? Can you check in this NI Max, right? Are you able to launch it already? Are you able to see this thing called the USB device? Can you see it's called USB 6009? Are you able to see that, please? This one. Yeah. Are you able to see this device? I is magnify many times for you to see. Can you see this? Can no? Now I want you to take note on your computer. You see the USB device. What is the difference between the one at the top called the NI USB 6000, right? Remember last week we created this together? The 6000 and 6009, what's the difference? What do you think is the difference? Besides that, don't tell obvious things. Tell me more detailed things. Okay, what's the difference? Okay, look at the color of the USB icon or the symbol.
Oh, I thought that's just because of selection.
Yes, correct. Black and that one is like I don't know what you call it, gold or what, or orange or what some people say is orange. It doesn't matter. It's okay. But you want to note that when your hardware is plugged in, it is black color. You see the USB. You know what is USB symbol or not? You know you know the USB icon, right? The symbol is black color. It means that when it's black color, your device is physically connected. Do you understand? It is physical. You have a real device there. Now, if you unplug, the device will disappear. You can try lah. I mean, no harm. Later you plug back, it won't harm you lah. You see okay. Now I do it. I demo for you. You don't do lah. Maybe you're scared. Okay, I do for you. Okay, you see guys. Okay, now I deliberately unplug. Okay, unplug right. So what happened? Okay, wait my screen a bit quite because my mouse go haywire already. Where's my mouse? Okay, how come become? Oh, because I think I selected Zoom. Wait, I need to get rid of this. Jialat. How do I get rid of this thing? Wait because I call this. Okay, wait sorry let's just give it a moment. You go and switch the tool. Ayo. My overworked computer, poor thing. This computer overworked. because also recording, also talking, also demoing. So overwork. This poor fella. Okay, can ready. I think we can get rid of this guy. Just like the lecturer, we overwork also. Tired already. But never mind. But teaching is still enjoyable. Okay, coming back to here. You see this one, right, guys? You see my USB. You just observe. I unplugged already. I just show you. Physically real one. On my hand. I unplugged the USB cable. Okay, what happened to the USB symbol?
Cross.
Yeah, red cross. Where's the other two friends? You all go and go for some break, is it? We text them. You see the red color cross or not, guys? Wow, they all take break. Don't know where they go. Call them. Where's Yeah. Okay. You see that you can try lah, no harm lah. You unplug the USB, you show red color, right? It means that your device is disconnected, which is obvious, right? Okay, you see Now I want you to pay special attention to look at the device, the assigned number. Do you see called device 2 or not? Yours should be device 2, right? Yeah, because earlier we did last week where we created a simulated device 6000, correct? And it was assigned a device 1. So this number is assigned by the computer. Okay, so now I'm going to put my thing back. So the device should become live again. Now, we created the USB simulated one. It will show as gold color. Okay, now later you will see why. Why is it useful? You created this simulated deck, right? You can try at home. You can still play around with the lab view. Okay, even though the hardware is not physically present, but you still can do some programming. Okay, so I think it's very good idea because NI quite smart. They created this idea. You know why they want to create this simulated deck? Okay, give you an example, use case. Why is it useful in the real application, right? If the engineer, right, imagine you are the company engineer. You're doing a project, imagine. Now, every time you do project, you may need buy hardware, right? So imagine. Now, let's say the company, you put up the hardware, okay, then they say that the delivery take 2 months. You imagine what is the problem? So you mean the engineer can shake leg for 2 months? No need to do anything, no hardware, or you tell the boss. The boss not going to be happy, right? He hire you, cannot be you do nothing 2 months. I waiting for my hardware. You tell him like that. The boss will not be happy, right? Make sense, right? So what do? Luckily, got this simulated deck. Why I can create a simulated deck? I can still do my work. I can still develop my hardware, blah blah blah. Then when the hardware arrive 2 months later, I plug in, I straight away can connect. Make sense? Smart. I think this is to me is a smart thing, right? So that your development work cannot stop. You must continue to do. Okay, with the whatever resource is provided. Even you create a simulated channel, you can still carry on. You understand? So this one I give you the background first. So okay, so you click on the 6009, this hardware. Can you everybody do this? 6009, then click self-test. Hey, where's our friend? Ivan, where you go? Shungi Kena caught no? No lah. Okay. Careful, got warden walking around. Y'all is okay. Careful lah. Just thinking. Okay. Yeah, seriously. Got warden going around. So okay, self-test, right? Pass, right? Did y'all get this? Self-test. Okay, very good. So everybody can. Okay, so it means that the hardware is connected. Now the next thing, right? Of course you can. There's a short video to teach you how to test this DAQ. But we can do it together. Okay, so I'm looking now. If you ask me where I am now, you can look at page 10 and page 11. Basically, page 11. Okay, where we will test the DAQ. Okay, test the DAQ. Page 11. Yeah, the rest later then do. The theory part we try to use, as I say in class time. We try to make the best of the time. Use the hardware. Okay, as much as we can. Okay, now you can switch on the power adapter. turn on your power adapter, you should see your hardware all light up, like a Christmas tree. Can. Yeah, look at my screen. Look in front of me. Look at me. There, like Christmas tree, light up. You see all the LED, right? Light already. Okay, very good. Can. Don't worry. If the buzzing sound irritates you, right? What you do very simple. You unplug the USB cable, reinsert back. Then you should cut off the buzzer. Unplug your USB, then plug back.
I don't care buzzing sound.
No, that one kill the sound. Unplug the USB, then reinsert back the USB. Can? Okay, no sound already. Okay, so your board should be powered up. I hope you know exactly what I'm referring. Okay, now there are two red color LED on the board. If you look at the hardware itself, don't mistaken. The one at the left hand side, the one is just to indicate the power indicator. You know what I mean? Okay, there's a power indicator LED there to tell you that the board is turned on. Right? But the actual LED is on the right hand side of the board. Alright, if you just now watch the video. Okay, let's do a test panel, shall we? Can we click on this test panel? There's a test panel here. Can you click on this test panel? Everyone, follow. As we do, you should be recording. Also, this one very important step. Before you do anything, you must do test panel first. Okay, test panel. Click on test panel. You should see something behind launch, like this. Am I right? Okay. Now let's do the obvious things first. Alright, so let's do the digital one first lah. Easy. Okay, I'm going to click on the digital I/O. Okay, I/O stands for input output. Cannot. Digital I/O stands for input output. I/O. Okay, now I need you to focus. Now on this hardware itself, right? In front there's a laminated sheet of paper stick at the box there. Do you see? In front, you must see where, depending on your orientation. I'm looking at the box. Have that piece of laminated sheet of paper face you. Facing you. The paper, right? Face you. Looking. That means you are looking directly at it. Okay, looking at you. Okay, now in fact the piece of paper information is very important, right? It tells you a lot of things. Okay, now I want you to look at that laminated sheet of paper. Everyone, don't look at me, look at your box. Look at your box, look at that label, because in the box there are four very important things. All right, you got analog input. Am I right? Right, analog input. That one is for what? What is AI0? What do you think? Analog input channel 0. Okay, can you see? And what is the thing connected to? AI0, can I ask you? Temperature sensor, very good, which is the LM335. You want to write down also if you want. Temperature sensor is LM335. Okay, that's channel 0. By the way, AI0 stands for analog input channel 0. Okay, because it is input, you are reading. Analog input channel 0. Right, under the analog input temperature sensor. Okay. Now everybody should do the self-test. Remember, the first thing to do when you come to the hardware is to do a self-test first. Alright, always do a self-test. You must see this part. Anybody don't have this self-test pass completed successfully? Anybody who don't have, better raise your hand. Have you passed the test? Then this one, the self-test. quickly raise hand. Then Mr. Teo can maybe assist a bit. Mr. Teo and help to check. Riwan, how can self-test? No, you self-test first. Have you passed the test? Hey, you all must follow, hey, friend. Self-test? Just now your exercise 1B, I haven't, did I sign already? I signed, right? I didn't sign. Okay. Yeah, I couldn't see your screen, yeah. Okay, self-test must pass. If your self-test don't pass, you don't need to do any other thing already because the communication not there. Okay, don't talk about self-test panel. Okay, after this, right? Okay, go to your digital IO. Now I'm going to test. Okay, I'm going to do. Okay, so what I'm going to do. Now, some of you can refer to page 11. There are steps there. Page 11 of your lab sheet. Now, as a part of a good engineer in training, you all are good engineers in training, right? Is to be able to follow instruction. Very important. Given a instruction sheet like this, you should be able to execute and follow the instruction as being described. That's a good engineer. Good engineer must do that. But I'm helping you here. So let's try to do the first one first. Okay, let's control the LED, shall we? Now, the LED will belong to a group called digital output. Am I right? Digital output. Look at the label. Look at the label. Don't look at me. Look at the label. The box there. Okay? Look at the label. So I want digital output. Am I right? Because the LED is something that I want to control. Okay? So I noticed that there are 4 LED and 1 buzzer. Agree? Okay, read carefully at the label again. What is red LED? What is P0.0? What do you think? Port 0. Yes, line 0. Better write down. P0.0 means port 0, line 0. So of course you got port 0 and line 1, port 0 and line 2, port 0 and line 3, and then port 0 and line 4. Am I right? So each is connected to different things. Okay, so how do we control this guy? So can I ask you to choose all output first? Select all output. Now be careful. This one, I want to be careful first because later the buzzer very chao, very noisy. Then the whole class all turn on the buzzer, then don't know what to do. They cannot switch off. Okay, I teach you first. Okay, everybody follow. Now tell me the buzzer, right, is which line? Can you tell me? I know it's port 0 now. Port 0. I already configure all output. That means I'm going to send signal out, right, to the port. Okay, so it's port 0 line 4. Thank you very much. 4. 4. Okay, so how to count this 4? Can you look at here, please? Everybody, attention. Look at my whiteboard. I zoom out. I magnify big. Okay, you see where is it? This one. Here. This one. Okay, so 0 is on the right hand side. So 1, 2, 3, and 4. So this is the button. If I press, it will turn on the buzzer. Right, no programming, you see, don't all just play the panel, never do any programming, right? So this one I want port 0, right? So in order to play this thing, so-called, you need to click start. Okay, follow, click start, then you click, okay, the default is turn on because it's inverted logic. That means it's turn on first. So in order to switch off, I want you to click on the line 4. Okay, so some of you may wonder, hey sir, where's the buzzer, boy? I don't see any buzzer on the box, right? Okay, the buzzer, right? If you just now watch the video, the buzzer is placed inside the box. Okay, there is a perforated hole. If you see very carefully, there's a small little opening hole, right, on the box itself. The buzzer is placed below, and the output is come out from the tiny little hole. Do you understand? So you can control the on and off. You see, okay. Okay. Now, as you are playing with the buzzer, you can switch it off. After you play already, okay. Now I know this button can control the buzzer. I want you to play the so-called click on the other switches to see the respective LEDs. So I'm able to turn on all my LEDs based on line 0, line 1, line 2, line 3. Do you see? Okay, fun So no programming at this point in time. Nothing is needs to be programmed. Okay, and then you turn to page 12. Can you write down uh, that table? Table, I don't know what table is it, 7A. They ask you to state the color of the LED. Okay, so be careful. Some students say yellow or some say orange. No need to guess. No need to guess. Why? Because if you look at the piece of laminated label there, everything is there. So there's only red, yellow, green or orange. Can you please write that down? Page 12. Page 12. Please write down. Okay, so that one is the LED. So in order to control the LED, can you switch off the buzzer? I don't mind. After a while, everybody later get ringing ear. Very bad. Thank you very much. Thank you so much. Okay, so can you write down the thing? Yes, so easy. Very easy. No programming. No programming at all. Very simple. Later the lab view even easier. Later you see. You want to control hardware. Super easy. And very fast. That should be the way. All right, control. Write down. What is the color of the LED? Okay, and then the line 4 refers to the buzzer. Everybody should be able to do it. So that is for port 0. Port 0, okay? I think you can guess what is port 1. What do you think is port 1? Okay, let's stop this thing first. Remember to stop after you finish trying out. Click the stop button. Yes, correct. The port 1, obviously, if you select here, port 1, I think you've done the port 0 already. Let's play with port 1. Port 1, what's port 1? Okay, how to choose? Select the port There, here, port 1, look at my screen. At the top, the left hand side there, you got this thing called port 1. So if you choose port 1, we're going to choose all input or by right default, when you choose port 1 means it's input Okay, now how to play this thing, how to try out. So you see all input, right? Okay, then you click start Then you try to press the push button. Okay, push button. You see I can get the input. So you must be very clear the direction of the flow. When you press the push button, you are sending an input signal to the board. You know what I mean? To your computer, right? So I can try out. I can press the green button, yellow, black, and the red. Make sure you can capture those. Okay, that is on page 13. Okay, pretty simple. Pretty simple at all. So far, so good. So far, so good. I hope I can. So you write down for me page 13. What are these buttons? Very simple only. Page 13. The answer is on the laminated sheet of paper. On the hardware. Okay. Very, very simple. Okay, can So done already. Okay, so we are done. So I click stop. Now I'm going to ask you. Okay, everybody follow. Who don't follow, better raise your hand. Hey, who cannot start one or don't know what I'm talking about. Please. Why? Everyone, yes.
Analog. You find analog.
Analog output, is it? Which channel? Correct. AO channel 0. Is it? Analog lamp. Wait. The lamp one. Okay. Maybe I quickly move to the lamp. Okay. Make sure you click stop first. Hold on. Click stop. Those of you who try out the analog output, can you click on this analog output? Okay, guys, ladies and gentlemen, can you do this, guys? Analog output, right? Can you wait, quickly? Can you select analog output? Yeah, I'm going to turn on the analog signal, send it to the turn on the lamp. You know what's the lamp? Turn on the lamp. Mr. Teo, maybe 放他一下. Right, Mr. Teo. Those on the lamp one, your question is what? What's your question? So now okay. Oh, it's stuck now there. Now just leave it. Now is no. Okay. Wait. Now go to analog lamp first. Can we go at the analog output, guys? Okay. I want device 2, but I want channel 0 because I want to switch on the lamp. Okay. So it's analog output channel 0. This one, guys. Make sure you can see the setting. Can you slide the slider here? Yeah, maybe say put about 4.5 volts, roughly speaking. Something like this. There's a slider, right? Slide this guy. Maybe about 4.5, then you click update. Okay, so you should be able to turn on the lamp on your board. Can no harm. You can put 5 means max. Then you can switch on. But sometimes very dim the light. Can you see the lamp turn on? Justin, cannot see. Where's the lamp? Do the next step. Don't daydream. Come, everybody. Let's move on. lamp, switch on. Okay, turn on the lamp already. Okay, good. So you must click update. Remember, when you update, you will update this value to the hardware and you will switch on the lamp. Okay. You will must. What voltage you set? 5 really, but the very dim, right? Yeah, that one is bo pian. The bulb a bit edge. Sorry about that. The light bulb a bit edge. So the brightness not very there already. But need to change bulb. But never mind. I think you get the idea. Some of it very bright. V1 I can see was so bright. Some very dim. Mine also very dim. But doesn't matter. You just need to know that the lamp can be switched on. Anybody cannot switch on the lamp. Why?
I don't know whether it's me or the hardware.
So means what? Are you able to?
I cannot turn on the lamp.
Cannot turn on the lamp. Mr. Teo, maybe help. Sometimes the bulb not tightened properly. Need to twist a bit. Then the thing sit properly. Sometimes it's contact problem. Okay, but mostly I can see on this table here. On my left hand side, I can see. I see the lamp. That means you're all following the procedure, doing properly. Okay, good. I can see all the lamp all light up. Okay, good. Okay, so I'm going to switch it off. Can you switch it off also? Let's slide it back to 0 and then click update. Okay, so that one is done already. Very simple. Now, what if we want to do the next part? Click stop. Okay, we look at analog input, shall we? Okay, so analog input, there are 2 things that are connected here. Okay, so the 2 things are basically the temperature sensor and the light sensor. So let's try and quickly do it. Okay, for the analog input, okay, I'm going to choose AI0. I believe by default it's chosen already. AIO, do you see? Don't run first. Okay, so you will see that this software very powerful. That means that for any other NI hardware, they come with it. You have all these utility tools. You can straight away test the hardware. As an engineer, I don't want to spend time writing code to see something. What's the point? I want to quickly test my hardware working or not first. Then I later talk about programming. Okay, I want to test very fast. You know what I mean? If you imagine you got to do this in Python or C, wow, you may spend a lot of time. You want to write the driver to talk to the hardware, it's already a headache. Okay, unless you got libraries. You know what I mean? Otherwise, you spend so much time. Only do 2 weeks. do 2 weeks just to talk to the hardware. Wow, already my project no need to do already. You know what I mean?